Hey, what's up? It's your old pal, Mr. Cook, and we're going to go through this review for the part two test of Unit 4. So, this is all about integration techniques. This first video, I'm just going to go through and kind of describe, how I pick the method that I'm going to use for each one of these. Because half the points you're going to get on this test is just the method that you pick. So, just, remember to pick the right method. And I'm going to go through it and kind of say hey, this is one you should have memorized. Here's some clues that help you to decide if it's a U sub. Here's a clue that tells me what kind of algebra technique I should use. And here's a standard integration by parts or something that benefits from integration by parts. Okay. And that's kind of the way that I look at it. First off, I look for the memorized stuff. So there's this big old list of antiderivatives. And if you know that list, you can use them. You don't need to show any work. It's pretty obvious when you see one of those. Two, that's when I see a U substitution. And this doesn't count simple U subs, because there are some U substitutions that you can do where you don't have to write U equals and all this stuff. It's just something that you can kind of memorize. And I don't know, I kind of put that under the first one as well. If I can just recognize that it's an easy U sub, I kind of consider that one a memorized one as well. So I always look for those kind of first. And then a more standard U sub. If it's not a more standard U sub, then I would try some kind of an algebra trick. And the algebra tricks are all the other stuff that we learned about in the different sections in Unit 4. There wasn't anything really outstandingly different about the way that we do an antiderivative. It's more about what we do with the function itself. Sometimes we make the function look different from substitution. Sometimes you make it look different through using an identity or just using some simple algebra properties to find it otherwise. So this would be your trig integrals, where we use identities, or maybe it would be partial fractions, decomposition. That could be another thing that we could do, or just some simple algebra property, that we might use. Or it could be a trig substitution problem. Those ones are useful as well. All right. Then the fourth one, if all that fails, or if I notice just right away that it's an integration by parts problem, I just use integration by parts. The standard integration by parts problems that you will see it would be something like this. If you saw x or x squared or x to the third or x to the 21st or whatever times, either e to the 2x or e to the x, or a sine function, or maybe it's cosine instead. Any of those things, if I saw any of that stuff, and x to any power could even just be x, that would be a very obvious integration by parts problem. And if I saw the standard, cosine of e to the 3x and maybe or e to the, cosine of 3x times e to the 4x or something like that, right? Those would be the ones where I do integration by parts twice and then subtract and then divide by the constant. So remember those ones as well. Those are very standard integration by parts problems. Okay, so with that in mind, I'm going to go through these problems, all 50 of them, and just describe what method I would use for each one of them, and maybe say something about each one of them for a couple seconds or something. One, that's an easy memorized technique, so just use memorization for that one. The next one, okay, so it's not a memorized technique, but I do notice that I have a function on the inside. So if we have a composition, think about U subs. And I really quickly just kind of go through it. U is equal to 3x to the fourth plus 6. And when I take the derivative of that, then I get, it looks like 12x dx. And sure, 12x, 12x to the third power, gosh. And then dx. And sure enough, I've got an x to the third here, and I've got a dx here. So then it's just a difference of constants. So this would work as a U sub. So that's what I would use. U sub for this one. Sorry, in case you can't tell, I'm a little sick right now. So if I need a pause for a cough or something like that, you'll forgive me. All right, so next one. 1 plus cosine of x over sine of x. So it's not a memorized one. It's not a U substitution, because if I let sine equal U, right, then that means that I would need a cosine all by itself times dx, right? But I have this plus 1 right over here. So it's not quite what I'd want to do. So not memorized, not a U sub. Let's try an algebra property. So something really easy that I could do with this is just split the fraction apart. That's always really helpful if you have a rational function and you have like a single term in the denominator. So if I split it apart, it can become 1 over sine of x, which is the same thing as cosecant, by the way, plus cosine over sine, which is the same thing as cotangent. And both of those, cosecant and cotangent, are like antiderivatives that I have memorized. So these would just be memorized rules after an algebra trick. So I'd just use an algebra trick, and then I would go to memorized after that. And I'll make a separate video going through all of these problems. So maybe like 10 at a time or something like that. But in this first one, we're just going through which method I would pick for each one of them. Because again, if you just know the method, that's half the test right there. So just picking out which method that you would use. Okay, so number 4, I have x times the sine of 2x. That fits under one of those like standard integration by parts problems. I don't even need to look at any of the other things. If I see something like x times the sine of something with x in it, or cosine, or e to the x or whatever, like x times any of that stuff, integration by parts without a doubt. So I'd have to do integration by parts just once on this one because I'd be able to get rid of that x really quickly. So integration by parts for that one, and only one time. 5, that's a simple u sub. I let u equal 3x, and there's just e to the u, so that's an easy u sub for that one. 6, so usually when you see a natural log, you should think to yourself, I've got to use integration by parts, okay? Like that's usually the place that you end up with, but always try to do a u sub first, okay? Because every now and then, that's why we have this ordered kind of structure. We do u sub first and then integration by parts. But when I see a natural log in the graph, it's not a trig thing. It's not a simple substitution usually, or a simple antiderivative usually. It's either going to be integration by parts or u sub. So I start off by just saying that u is equal to the natural log of x. And then the derivative of that is 1 over x dx, right? And if you look closely, like if I just split that thing apart, 3 and 3 to infinity of like 1 over x times 1 over natural log of x to the second power, and then dx. Like check it out. I've got the natural log of x here, so that's the u, and then I've got the 1 over x dx, that's the du. So yeah, this is like a perfect u substitution. So this is a u sub, and on top of that, if you look at the bounds on this definite integral, it's also improper because of that infinity right over there. So this would definitely be a u sub again, and then it's also going to be improper on top of that. So I've got to use limits and things like that to resolve it. Okay, with number 7, sine to the third and cosine of x. So it's not a simple one. So I go to u sub. Well, I've got sine to the third of x. That's a function inside of a function. So I'd say that sine of x is equal to u. And I'd see if it works as a u sub. So du would be equal to cosine of x dx. And sure enough, I've got a cosine of x dx right there. So this is a simple u sub. 1 over, okay, I mean, we've seen this problem a bunch of times. This is a partial fractions problem. So this one, you use algebra, and then from there you use a simple u substitution for this one. We call it partial fractions, but that's what we're basically doing. 1 over x squared plus 16. Yeah, this is one of those trig substitutions. It's going to lead me to, creating the triangle and all that stuff. If you recognize it as arctangent, you can also use that. But I'll just say that it's going to be an algebraic kind of like change. So I'm just going to do this one as a trig sub, but you can use like a memorized technique. And then this is just going to be like a trig substitution is really just a u sub, so it's like a substitution at that point. That's pretty easy. Or using memorized ones that you see. Number 10, this one has a tricky algebra technique that you got to do first. So basically, like what you do is, so for this part, you split apart that exponent. So if you have e to the x plus e to the x, this would be the result of, so let me kind of like show you the algebra trick I'm going to use. If I had like 2 to the third and I multiply by 2 to the fifth, that'd be the same as saying 2 to the 3 plus 5, right? And so what this is doing is I'm going to pretend that this stuff here is here, and then I'm going to split it apart. So I'm going to use that same property and say that this is the same thing as saying e to the x, and then times e to the x. And then this problem gets really, really easy from there after this little algebra trick. because after the algebra, all this is going to be is it's just a u sub at that point. At that point, that's it. 5 cosecant squared. So cosecant squared is one of the memorized ones that we have. So that should be pretty easy. E to the x is another memorized one. X squared times sine of x. That's integration by parts, without a doubt, because again, it's like, x to some power, who cares, whatever it is, times sine of something, whatever, dx. So there you go. Sometimes this can, this little pattern can be a u sub every now and then if it looks like this. Like if I had x squared on the outside and instead of just a regular old x on the inside, I had like x to the third. You see why that would be a u substitution? Because if I let u equal to x to the third power, then du would be equal to 3x squared dx. And see, I've got like that x squared and maybe the dx out here. So I'd be able to do a u sub in that case. But so, you always want to try to do u sub, of course, first to see if it works. But this is a standard integration by parts problem because we just have x to the first power. And you can just kind of look at it and say like, well, the derivative of this is not that. So, it's just going to be something else. So we got to use integration by parts. In this case, you'd actually have to do it twice because of that x squared. 14 would be another trig substitution, although could be a memorized one if you want. I think this ends up being like arc sine or something close to that. But if you didn't spot that initially, you could just say that this is going to be a trig sub. And trig subs are just like, u substitutions. So you just work through it. It's not that bad. Number 15. So let's see. Oh, look at that. X cannot be equal to 2, which is like in the middle there. So this is an improper integral, but it's also a u sub. So it's a u sub, and then also it's going to be improper. So you got to do all the limits and all that stuff on top of it. So, watch out for that. Okay, 16. That's just a power rule. So that's a memorized technique. That one should be pretty easy. 17, that's going to be another trig substitution. I think this ends up being like an arc tangent or something also. But yeah, trig sub for this one all the way. Secant tangent, that's another memorized one. X squared e to the x. That's like x squared sine of x, where it's like integration by parts. All right, that's what I was writing, IBP. And I'd have to do this one twice because of the x squared. So, 2 of those. Okay, and then after that, let's see here. So I see that x squared plus 3x, if I let that be equal to u, then the derivative would be 2x plus 3. And it just so happens that 2x plus 3 is this thing divided by 2 times 2x plus 3. So this would just be a simple u sub for this one. Okay, and then 21, that would be another u sub. And also it's going to be improper because 1 is in that boundary right over there. So I would use improper integral for this one, but it'd just be like an easy u substitution to get this thing taken care of. Okay, and then let's see here. Let's try and do the derivative for this, the bottom part, because that might give me the numerator. X to the third minus 2x minus 8. Let's see if it can be a u sub. Du would be equal to 3x squared minus 2. Yeah, sure enough. This is just a simple u sub on this one. Sine to the third of x times cosine to the fifth of x. So this would be one of those trig integrals where you got to use identities. Pardon me, sorry. So here's what I would do with this one. I would I noticed that like I've got a cosine to the fifth here and a sine to the third here. So if I used sine as my u substitution, so let u be equal to sine, that means that I would need a cosine of x as well. So what I'm going to do is like I'm going to pretend that I'm going to use sine on this, like for my u sub. So that means that would be u to the third. And then I would need 1 cosine of x dx from this. So if I branch off and take one of the cosine of x's from there, I would be left with cosine to the fourth of x, right? Because if I took one of them and the dx away, that means that I'd be left with a cosine to the fourth of x. And then, the rest of that would turn into a du, right? Because if I took a cosine from here and then the dx, that would turn into a du, right? Okay. So then if I have cosine to the fourth, that's the same thing as saying cosine squared of x, and then times cosine squared of x again. And every time that I see a cosine squared of x, I know that I can turn that thing into a 1 minus sine squared, right? Because there's that Pythagorean identity that says that cosine squared of theta is equal to 1 minus sine squared. And it just so happens that sine is equal to u. So this would be like saying that cosine squared is equal to 1 minus u squared. And that's what I would do. I'd replace both of these guys with 1 minus u squares. And then the rest of it would be pretty easy. So I could rewrite this as u to the third. Then cosine to the fourth becomes cosine squared times cosine squared, which would be 1 minus u squared. And then finally, I'd have that little du there right there. And then from here, I would like FOIL this out and then distribute this and then, finish up my u sub. So this would be my little trig integral thing. So, but it ends up being like a trig integral to a u substitution for number 23. For 24, this one is like another memorized one. I rewrite that as 2 over x dx. And remember that 1 over x is natural log, so that's a memorized one. Secant and cosecant, those are both memorized ones. 27, let's see here. So I can't use 4 for x. 0 for x. I also can't use negatives for x. So that means that there's nothing in the boundary that's a problem, but that infinity means I got to do an improper integral. But first I do an algebra trick. I'd like, realize that that's x to the first and x to the 7/2. So I'd reduce that down first to x to the negative 5/2 instead dx. And then I'd use power rule, and then I'd use the improper integrals for that one. So this is algebra, and then a memorized technique, and then improper integral. 28, that's going to be just a typical u sub. So you can actually use a trig substitution here, but this is an easy u sub. If I let u be equal to 16 minus x squared, that means that du is going to be equal to negative 2x dx. Now I've got an x from here, right? Because x to the third is x squared times x. So I can take out that x and that dx right there. With that, so I could turn it into a du. And then I've still got to get rid of this x squared, but I can solve for x squared from this equation, right? So if I get x squared by itself, x squared is equal to, let's see here, that'd be 16 minus u. So I just replace the top part with 16 minus u. And then the bottom part would be over the square root of u. And then I'd split the fraction apart. So 16 over the square root of u minus u over the square root of u. And I'd reduce them. And then I'd just use my memorized techniques to solve that one. Sine squared and cosine squared, if you see those, that's a really easy one. That's like the power reduction rule. So the power reduction rule, it's like one of the identities that you have in 4. What would it be? 4. I think it's 4.7 or 4.8, the trig integrals, because one of the identities is sine squared is equal to 1 minus cosine of 2x over 2. And that's what you would reduce. So you just change that into 1 minus cosine of 2x over 2. And then split the fraction apart, 1/2 cosine of 2x over 2. And then, take the integral of each individual part. Cosine squared is really easy. All you have to do is just it's the same thing but a plus instead. And I think we even did that in the notes, so you can check your notes for that one if you want. But same deal. 31 and 32. Let's see. So if this factors, then it's a partial fractions. If it doesn't factor, then it's going to be either a trig substitution, or if you've memorized arctangent, you can just use arctangent for these ones. So let's see here. Does the first one factor, number 31? So I'd try to factor the bottom part. Are there numbers that multiply together to be negative 14 and add together to be negative 5? Yeah, there are two numbers that do that. That'd be negative 7 and positive 2. So that turn into x minus 7 and x plus 2. So this one I would use partial fractions to solve. 32. There aren't any numbers that multiply together to be 38 and add together to be 12. So I'd have to complete the square on this one, on the denominator. So it'd be 1 over, and then that would be x minus 6 squared, and then plus 38, and then, let's see, negative 6 squared is 36, so then subtract 36. So that'd be 2. So that's what I'd be working with, and this could either be a trig substitution, or it could be an easy one if you memorized the arctangent pattern. Okay, so either one of those, but you have to complete the square first, and then you have two options after that. 33. So first thing that I would do is recognize that 1 minus sine squared is an identity. So I would just think to myself, well, what happens if I turn that into cosine squared? So then if I turn it into cosine squared, it's really easy, right? Because cosine squared over cosine just reduces down to cosine. And then you see what I'm talking about? It's just like a memorized rule for that one. X e to the x, that's another really popular integration by parts problem. Because remember, if you see x times e to the x, or x times sine of x, or x times cosine of x, then it's typically going to be an integration by parts problem. You always want to check to see if it can be a u sub. Just kind of like do the steps in your head. But typically, if it's just like regular old x's, it's going to be integration by parts. And you should be able to get this done after just one round of integration by parts. Okay, we're on the home stretch. Cosecant to the fourth times cotangent, those are part of an identity, cosecant squared and cotangent squared. So again, what I would do on this one is like just try to see if it's a u substitution, and then using identities to kind of iron out the rest of it. So I would say like, okay, well, if I use cosecant as u, so let u equal cosecant of x, then du would be equal to negative cosecant of x cotangent of x dx. And yeah, sure enough, I can grab like a cosecant from here and a cotangent from here, and a dx, and that would give me the du. So here's what I'd be left with. So if I took one cosecant and one cotangent out of that, here's how it would look. So it'd be cosecant to the third of x times cotangent to the second power of x, and then times, and then I'm taking out a cosecant and a cotangent from both of those. So now I've got a cosecant of x, cotangent of x, dx. And look at that. I've got cosecant of x, cotangent of x dx. So it looks like I can do a u sub on this one. So I get from the cosecant to the third, that becomes u to the third. And then we'll talk about the cotangent squared in a second. And then cosecant cotangent dx becomes a negative du. Now, cotangent squared is part of an identity. So 1 plus cotangent squared of x is equal to cosecant squared of x. So if I want to get cotangent by itself, I just subtract 1 from both sides. And that's what I'm going to replace in here, because cosecant, remember, is u. So cosecant squared minus 1 is the same thing as u squared minus 1. So cotangent squared is u squared minus 1. So that's what, I would put in its place. Then I would just distribute that u to the third in there, and then use the u substitution to finish this thing off. Okay, this one looks like, well, first off, it's improper, right, because of the infinity there. But then also on top of that, x squared's derivative is 2x. So this looks like it's just going to be a simple u substitution for the derivative. Then an improper integral with all the limits and all that stuff. 37. So for 37, let's see here. Secant and then tangent squared. Oh, well, tangent squared plus 1, that's another identity. Tangent squared plus 1 is just secant squared, so this turns into secant of x excuse me, over secant squared of x dx. One of the secants will cancel in the top, so secant in the denominator, and then 1 over secant is the same as cosine. So this is really just like saying cosine, and then that's a memorized one from there. 7 e to the 5x, that's a simple u sub. Cotangent, that's a memorized one. Let's see here. This is a tricky one. This one's called a u sub and also an integration by parts. Because what you would do is you would let u be equal to x squared, right? So that would be the u right over here. And then the derivative of x squared is going to be 2x dx. So you can pull one of the x's from here and the 2 from here and the dx here. So here's how you can rewrite it. It'd be like 2 times x squared times the cosine of x squared, and then times dx. So look, you can take the 2x and the dx from here, and then this x squared over here becomes a u, so cosine of u, and then du. But then this other x squared also becomes a u. And does that look familiar? What if I wrote it like this? X times the cosine of x. See, it's integration by parts at this point. So this is a u sub and then an integration by parts problem after that. It takes some time, but you can get it done. Pardon me. 41. So let's see here. It looks like 1 I'm not allowed to use in there, and then also infinity. This is improper. But the antiderivative itself is pretty easy. Like this is another u subs, because if I took 1 minus x to the third as u, then du would be equal to negative 3x squared dx. See, I've got an x squared and a dx there. So u sub would be the way that I would solve this, then do the antiderivative stuff. Secant to the second power, that's a memorized one. T minus 3 squared, that would be a u substitution. So this is one where you'd let it be equal to t minus 3, but then du is equal to dt. So if I like started to simplify stuff or substitute the stuff out, here's what I would get. So if I had 2t in the top, t minus 3 in the denominator becomes a u, so that's u to the second. dt is du. But then what do I do with that t right there? Do you remember what to do with this one? That's right. We use this expression over here to solve for t. So if I get t by itself, t is equal to u plus 3. So that means that this turns into 2 times parentheses u plus 3 over u squared du. And then distribute the 2 in there, split the fraction apart, and it's pretty easy from there. Tangent, that's a memorized one. Cosecant, cotangent, that's a memorized one. X natural log of x, this is integration by parts. This is another one that we did in the notes. This is a pretty easy one. And remember that, like, if you're just trying to figure out which one to use for u, either x or natural log of x, remember there's like an ordered tier by which you want to do it. I always remember it like this, the 8. L is, and I'm not going to take credit for it. Mr. Rupp showed me this. He did a great job in explaining this to me. I thought that was really cool. Natural log and log are the best ones to use for u in a standard like integration by parts. I, that would be like your inverse functions, arctan, secant, arcsine, all that. Algebraic answers, x squared, x to the 4th power times 3, those things. T is trig expressions like sine, cosine, tangent. E, exponential functions like e to the x or e to the 2x or e to the 5x or whatever. But notice that we've got a natural log right there. So if you use natural log for u, you should be able to get this thing all done. So x natural log of x dx, let u be equal to natural log of x, and then dv is equal to x dx. And this is really easy after that point. All right, 47. So with number 47, what you do is, let's see here. Well, you got a bunch of like trig expressions, and when I was teaching honors algebra 2, I would tell kids like when they had to do analytic trig just to change everything to sines and cosines if it's like more than 2 trig functions or trig ratios. So that's what you should do here. Just change everything to sines and cosines. So sine is fine by itself. Secant, that becomes 1 over cosine. And then tangent becomes sine over cosine. And then just start, working with it algebraically. Like if you're dividing by a fraction, it's the same as multiplying by the reciprocal. So that'd be sine of x over cosine of x times all that other stuff, sine of x plus 1 over cosine. And then, what you would do is just distribute, and things work out real nicely. 3 natural log of x squared. This is a u sub, because if you let u equal x squared, you can just substitute out the u. That one's pretty easy. 1 plus sine squared. Let's see here. Well, 1 plus sine squared, that's not actually cosine, but I think that you can actually like work with this a little bit. Yeah, you can, since sine squared is a function inside of another function, if you let u equal to the sine of x, this actually is a really easy u substitution. So this is a u sub. And then for number 50, you just break apart the integral and solve it easy. So it's just memorized in simple u subs. Okay, so that's all 50 problems and like a way to work through them. And then in future videos, I'll go through each one of them based off of what they are, memorized technique or trig substitutions and all that kind of stuff. I'll break it up into the different videos. All right, well, thanks for watching this video. I hope it was helpful. I know I went fast through it, but I had 50 problems to go through in a short-ish video. So if you need help, don't forget to contact your teacher. All right, happy studying. Bye-bye.